बिस्मिल्लाहिर्रहमानिर्रहीम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली. Dear students, today we are going to start lecture 4 of Signal and System course. This short lecture we will be discussing some basic operations which can be performed, which are normally performed on continuous time and discrete time signals. This course of signals and system, as the name implies, is basically about the study of signals, various kind of signals, and various kind of systems. So normally systems, when we will talk about them, and we are going to talk about them very soon, inshallah. The system's task or the function is to perform certain operations on the input signals. So they manipulate the signals in one way or the other. So what are different type of manipulations which are performed by the systems on the input signals? We are going to discuss them today. So basically we are going to discuss a number of different operations uh, which which are called, for example, the first operation we can we call it the magnitude scaling. So this operation of magnitude scaling is performed on the dependent variable. So when we have a signal, we have an independent variable, which is normally time for continuous time signal, and uh, which we denote by t, and which we denote by n for discrete time signals. So that is called independent variable trn, whereas the amplitude or the magnitude of the signal is is a dependent variable. So this operation of magnitude scaling, this is performed on dependent variable, whereas the remaining operations like time shifting, time scaling, and time reversal are normally performed in on independent variables. So we are going to discuss these very basic operations. What are they? How they change the shape of our signal, and how many different ways these operations can be performed. So let's start. Okay, so the first operation which is normally performed, which can be performed on signal, is called magnitude scaling. So let's suppose we have a signal which we here we are calling it f of t. So this is the signal f of t, a continuous domain signal. So an operation on its magnitude, uh, any operation which is performed on the magnitude of this signal, and what we do, we multiply that signal f of t by a number k, where k is called the scaling factor. This k could be greater than 1. For example, here k is greater than 1, so you can see that in this case this function g of t, which is equals to k f t, since k is greater than 1, so that so g of t is an amplified version of f of t, or the amplitude of signal g of t at each point is greater, is enhanced as compared to f of t, because the scaling factor k is greater than 1. Similarly, if the scaling factor k is less than 1, then the magnitude of the resultant signal will be decreased. For example, here g of t is, which is equals to k f t, but k is less than 1. So here you can see that the magnitude of this signal g of t is less than f of t, because k is less than 1. This scaling factor k could also be negative, and if it is negative, which is shown over here, then the signal will be flipped. But please remember that the signal will be flipped around the horizontal axis, not about around the vertical axis. There is one flipping which is a flipping associated with independent variable, and in that case that is called time reversal, and in that case the signal is flipped around the vertical axis. But here when k is k is negative, the signal is flipped around the horizontal axis. So original signal exists, the magnitude of original signal is positive for these different values of t. It could be 1 or it could be 0.5 at some place, or it could be 0.25. But when we multiply it with a negative k, now this amplitude magnitude has been flipped. So now its magnitude may be at some point it is minus 0.5 or minus 0.25 or minus 0.35. So original signal has been flipped around the horizontal axis. Okay, so the next operation which is performed on independent variable, that operation has a name which is called time shifting. So time shifting a signal either delays that signal, delays mean right shift, or it advances that signal, which means left shift. And graphically this has been demonstrated in these three pictures. So this is our continuous time signal x of t. So if I delay this signal, at the moment this signal is going to start from here, but now I want to delay it in time. So I want कि ये signal जो है some later time पे start हो. So I will delay that signal, और उस delay को represent किया जाता है like this. Phi of t is x of t minus capital T. So this capital T is the delay in that signal. पहले ये सिग्नल यहाँ से इस पॉइंट से स्टार्ट हो रहा था. नाउ दिस सिग्नल is starting from this point. So this signal has been delayed by an amount which is capital T, and the resultant signal in this case is called x of t minus capital T. Similarly, the same signal x of t can also be advanced in time. So advanced means it should start a bit earlier than the original signal. Original signal अगर यहाँ से start हो रहा था और हम ये चाहते हैं कि ये इससे पहले स्टार्ट हो जाए, यानी एडवांस्ड वर्जन ऑफ सिग्नल. इफ वी वांट टू ऑब्टेन द एडवांस्ड वर्जन ऑफ सिग्नल, so this by the same amount capital T. So now the signal is going to start from this point. तो entire signal is advanced in time. ये पहले स्टार्ट होगा इस पॉइंट से पहले ये स्टार्ट हो रहा था ओरिजिनल सिग्नल. एडवांस्ड वर्जन सिग्नल का स्टार्ट भी पहले होगा, एंड भी पहले होगा. सो पूरा सिग्नल जो है वो टाइम डोमेन के अंदर जो है वो एडवांस्ड हो गया है. एंड दिस इज नाउ रिप्रेजेंटेड बाय दिस. फाई ऑफ टी इज नाउ गिवन एज एक्स ऑफ टी प्लस कैपिटल टी. सो अगर आपके पास जो है वो अगर आप किसी सिग्नल को टाइम के अंदर डिले देना चाहते हैं तो देन इट इज़ एक्स ऑफ टी माइनस कैपिटल टी. और अगर एडवांस्ड वर्जन यू वांट टू ऑब्टेन द एडवांस्ड वर्जन ऑफ दैट सिग्नल, देन दैट इज गिवन लाइक दिस एक्स ऑफ टी प्लस कैपिटल टी. सो टाइम शिफ्टिंग इज एन ऑपरेशन इन इंडिपेंडेंट वेरिएबल. प्लीज़ रिमेंबर कीजिए जो कुछ भी हम इसमें कर रहे हैं इसमें सिग्नल का जो मैग्नीट्यूड है वो अफेक्ट नहीं हो रहा. इन तीनों सिग्नल्स का जो मैग्नीट्यूड है वो सेम है. सिर्फ हो क्या रहा है कि जिस पॉइंट से सिग्नल स्टार्ट हो रहा था और जिस पॉइंट पे वो एंड हो रहा है वो पॉइंट टाइम डोमेन के अंदर, टाइम इस एक्सिस के अंदर, या वो पॉइंट इस ओरिजिनल के बाद में आ रहा है, in which case it will be called a delayed version of original signal, या वो उस पॉइंट से पहले आ रहा है. पूरा सिग्नल जो है वो शिफ्ट हो गया है either towards right or towards left. So right shifting is called a delay in signal and left shift is called an advancement in signal. सो पूरा सिग्नल जो है वो टाइम डोमेन के अंदर इंडिपेंडेंट वेरिएबल के अंदर जो है वो हमने उसको या तो डिले कर दिया है या उसको एडवांस कर दिया। Okay, so now let's talk about second operation which we can perform, which we can perform on independent variable. The second operation is called time scaling. So it is a little bit different than time shifting, which we discussed in the previous slide. Time shifting में ये होता है कि आपके पास वही सिग्नल जो है वो उसकी शेप चेंज नहीं होती। वो जो सिग्नल ओरिजिनल सिग्नल था प्रीवियस स्लाइड में जो हमने डिस्कस किया उसका डिलेड वर्जन या उसका एडवांस्ड वर्जन, ये दोनों वर्जन्स जो थे इनके अंदर सिग्नल की शेप सेम रहती है, सिर्फ टाइम डोमेन के अंदर वो या उस पॉइंट से पहले स्टार्ट हो जाता है ओरिजिनल से या ओरिजिनल के बाद स्टार्ट हो जाता है। बट इन टाइम स्केलिंग व्हाट हैपन्स दैट सिग्नल की जो शेप है वो चेंज हो जाती है, या आपका सिग्नल कंप्रेस हो जाएगा टाइम डोमेन के अंदर अगर आप टाइम स्केलिंग का ऑपरेशन परफॉर्म कर रहे हैं, या आपका सिग्नल एक्सपेंड हो जाएगा। So either it would be an expansion or it would be a compression. So depends, ये भी हम डिस्कस करेंगे, ये डिपेंड किस पे करता है, this depends upon the value of a. So definition is time scaling a continuous time signal xt by a factor a results in compression if a is greater than 1. So if a is greater than 1, then there would be a compression of signal will be compressed. जो पहले उसका फॉर एग्जांपल ये ओरिजिनल सिग्नल है आपके पास x of t, it exists from capital T1 to capital T2. Its non-zero values are in this interval from T1 to T2. So now if I obtain x of 2t, x of 2t means we have selected a as 2. Since a is greater than 1, so now this signal will be compressed. So here you can see from the waveform, now this signal exists between these 2 points t1 over 2 and t2 over 2, and और इसकी जो ड्यूरेशन है, जो इसकी एग्जिस्टेंस है, जो इसका टाइम ड्यूरेशन है, वो पहले की निस्बत जो है वो आपके पास हाफ हो गई है। सो अगर लेट्स सपोज आपके पास t1 जो है दैट वाज -2 एंड t2 वाज इक्वल्स टू +2, तो आपके पास xt सिग्नल एग्जिस्ट करता था बिटवीन -2 एंड +2, and now this signal x of 2t will exist between -1 and +1. So this will be a compressed version of the original signal in the independent variable. So ये उसी original signal का एक compressed version है। एम्पलीट्यूड के अंदर, मैग्नीट्यूड के अंदर इस केस में भी कोई चेंज नहीं आई। सिग्नल का जो मैक्सिमम मैग्नीट्यूड अगर फॉर एग्जांपल यहाँ पे 0 पे 1 था तो आपके पास जो इसका कंप्रेस्ड वर्जन होगा इसका मैग्नीट्यूड भी 0 पे 1 ही रहेगा। सिर्फ हुआ क्या है कि ये जो ड्यूरेशन है, जिस ड्यूरेशन में ये सिग्नल एग्जिस्ट कर रहा था, वो ड्यूरेशन अब हाफ रह गई है, अब आधी रह गई है। सिमिलरली another similar concept is time expansion, और टाइम एक्सपेंशन जो है उसमें ये होता है कि इफ वी सिलेक्ट एन ए विच इज लेस देन 1, then the signal, resultant signal will be an expanded version of original signal in the independent variable. So for example, original signal was non-zero between t1 and t2, and if we select a as 1 over 2 which is less than 1, so the resultant signal will exist between 2t1 and 2t2. ठीक है। सो अगर ये t1 फॉर एग्जांपल -2 था और t2 +2 था, तो नाउ दिस सिग्नल विल एग्जिस्ट बिटवीन -4 एंड +4। सो ओरिजिनल सिग्नल जो है अब टाइम डोमेन के अंदर एक्सपेंड हो गया है। एम्पलीट्यूड अगेन जैसे मैग्नीट्यूड जो है सिग्नल का दैट विल रिमेन द सेम। अगर वो 0 पे ओरिजिनल सिग्नल में 1 था तो यहाँ पे भी वो 0 पे 1 होगा, लेकिन अब सिग्नल ज़्यादा ड्यूरेशन के लिए एग्जिस्ट करेगा बिकॉज इट हैज़ बीन एक्सपेंडेड. सिमिलरली if you select a greater than 1, then signal will exist for less duration because it has been compressed. Okay, so uh, similar is the case for discrete time signal with one exception, and I will talk about that exception later on in a slide when we do an example of this time scaling of discrete time signal. But in the continuous domain, we have observed in the previous slide that you select the values of a either greater than 1 or less than 1, and the resultant signal is called either a compressed version of the original signal or an expanded version of the original signal. So here in the discrete domain, if for example we select the value of a greater than 1, then the resultant operation is called decimation. Instead of compression, it is called decimation. It in principle it is the same operation, but in terminology in the discrete domain, this process is known as decimation instead of compression. And similarly, if we select a is less than 1, then the resultant process in this domain is called interpolation instead of expansion. So what is decimation? When we select a as greater than 1, for example, if we select a as 2, so our signal y of k, which is x of 2k, so this will be called a decimated version of original signal x of k. And if we select a as 1 half, then this signal y of k, which is x of k by 2, will be called an interpolated signal of the original signal. So interpolation is a reversible process, but decimation is an irreversible process. So what it means basically, that if you have interpolated some signal, which means that you have expanded that signal as compared to the original signal, so क्या आप उस expanded signal से वापस अपना original signal obtain कर सकते हैं? तो yes, in case of this process, in case of interpolation, we can do that. So that's why it is called a reversible process. लेकिन अगर हम डेसिमेशन परफॉर्म करें, और डेसिमेशन में क्या होगा कि हम ओरिजिनल सिग्नल को कंप्रेस कर देंगे, सो वी विल लूज सम वैल्यूज ऑफ द ओरिजिनल सिग्नल. सो नाउ फ्रॉम दैट कंप्रेस्ड वर्जन ओरिजिनल सिग्नल रिकवर नहीं किया जा सकता. सो दैट्स व्हाई डेसिमेशन इज एन इरिवर्सिबल प्रोसेस, whereas interpolation is a reversible process. So interpolation से वापस आप ओरिजिनल सिग्नल obtain कर सकते हैं, but if you have performed decimation, so since you have lost a few values of the original signal, तो उस decimated version से आप original signal को दोबारा reconstruct नहीं कर सकते. Okay, so now let's talk about the third operation, this which is called time reversal. और टाइम रिवर्सल जो है, इन सम बुक्स यू विल नॉट सी इट एज अ सेपरेट ऑपरेशन, और उसकी वजह ये है कि टाइम रिवर्सल इज़ द सेम ऑपरेशन एज स्केलिंग इफ़ यू सेलेक्ट ए एज इक्वल्स टू -1. ठीक है, सो अगर आप ये भी आपको क्लियर भी हो जाएगा, बिकॉज इन दिस केस दिस वाज फॉर एग्जांपल ओरिजिनल सिग्नल x of t. Okay, so let's suppose we have a signal x of t which is shown over here. So it is non-zero from say -2 to 0, and then from 0 to 5. So the definition of its reflected signal is given like this: phi of t is x of -t. So this is a reflection of the original signal about this axis, vertical axis. So इस वक्त जो signal positive side पे मौजूद है, which is this portion, जब आप इसको reflect करेंगे तो this will exist for negative t। जैसे यहाँ पे ये 0 से लेके 5 तक ये सिग्नल पॉजिटिव t के लिए एग्जिस्ट करता था, सो रिफ्लेक्टेड सिग्नल में इट विल एग्जिस्ट फ्रॉम 0 टू -5। और जो पोर्शन ओरिजिनल सिग्नल में नेगेटिव t के लिए नॉन जीरो था, विच वाज फ्रॉम -2 टू से 0, that will here it will now exist for positive t. From 0 to 2 it will be non-zero. So this is a reflection of the original signal around this vertical axis, and that I told you previously when we discussed magnitude scaling that there is one reflection which is around this horizontal axis. जब आप सिग्नल के मैग्नीट्यूड को स्केल करते हैं और k की कोई ऐसी वैल्यू चूज करते हैं विच इज़ नेगेटिव, तो आपका ओरिजिनल सिग्नल इस वर्टिकल एक्सिस के अराउंड रिफ्लेक्ट हो जाता है। यानी अगर पहले उसका एम्पलीट्यूड पॉजिटिव होता है तो फिर उसका एम्पलीट्यूड नेगेटिव हो जाता है। बट हेयर वी आर not talking about amplitude, here the reflection is about the vertical axis. इस axis के along signal reflect हो रहा है। So phi of t is x of minus t, and this operation is being performed on independent variable, whereas that operation जो कि magnitude scaling का था, that operation is performed on dependent variable. Okay, now let's talk about a combination of these operations. Sometimes we are required to draw a few signals in which more than one operations are combined. So we have discussed three different operations. One was time shifting, then we discussed time scaling, and then finally we discussed reflection or time reversal. So now let's suppose we have to draw a signal. Let's suppose we have some x of t, and from that x of t we have to draw this signal x of at minus b. So this signal here you can see that we have to perform two operations. One operation is from x of t we have to generate this x of at, which is the scale version of the original signal. So that is one operation which we have to perform, and that is the time scaling. The second operation which we have to perform is the shifting. जो सिग्नल आपको x of t से x of at मिल जाएगा उसको फिर आपने शिफ्ट भी करना है with an amount b. So आपने दो ऑपरेशन परफॉर्म करने हैं. So now when you have to perform two operation, a natural question could be, क्या ये ऑपरेशन जो हैं वो किसी भी ऑर्डर में परफॉर्म किए जा सकते हैं या इनके लिए कोई स्पेसिफिक ऑर्डर होना ज़रूरी है? इस सवाल से मुराद ये है कि जब हमें x ऑफ t से x ऑफ at माइनस b जनरेट करना है तो हमने दो ऑपरेशंस परफॉर्म करने हैं, एक टाइम स्केलिंग का और एक टाइम शिफ्टिंग का. So the question is whether the order of these operation is important or not. ऑर्डर किस वक्त इम्पॉर्टेंट होता है और किस वक्त इम्पॉर्टेंट नहीं होता. अगर फॉर एग्जांपल आप कोई भी दो ऑपरेशन परफॉर्म कर रहे हैं और वो दो ऑपरेशन परफॉर्म करने से आपके पास किसी भी ऑर्डर में परफॉर्म करने से अगर रिजल्ट चेंज नहीं हो रहा तो फिर तो ऑर्डर जो है वो इम्पॉर्टेंट नहीं होगा. जो भी ऑपरेशन आप चाहें वो पहले परफॉर्म कर लें, जो ऑपरेशन दूसरा ऑपरेशन वो बाद में परफॉर्म कर लें. लेकिन अगर ऐसा हो कि आप एक ऑपरेशन परफॉर्म करें और एक सीक्वेंस ऑफ ऑपरेशंस परफॉर्म करें और उससे रिजल्ट कुछ और आए और दूसरे सीक्वेंस ऑफ ऑपरेशन से रिजल्ट कुछ और आए, तो इट मींस कि देन इट इज़ इम्पॉर्टेंट कि आप किस ऑर्डर में ऑपरेशन जो है वो परफॉर्म कर रहे हैं. सो हियर यू हैव टू चॉइसेस. फर्स्ट चॉइस इज दिस. फर्स्ट you can time shift xt by b to obtain xt minus b. So here you require x at minus b. So इनमें से एक ऑपरेशन हम पहले परफॉर्म टाइम शिफ्टिंग का फर्ज करें कर लेते हैं, तो xt को हमने b से शिफ्ट कर दिया. So we obtain x of t minus b. Then the second operation which we can perform in this sequence is to time scale the above signal. अगर हम इसको a से scale कर दें तो we will get x of at minus b, which is our required signal. So this was the first choice, the first case. The second choice is we can also do that. First we में टाइम स्केल द सिग्नल xt. सो अगर आपके पास xt है और उसको आप a से टाइम स्केल कर दें तो you will get x of at, and then you time shift the given signal by this amount b over a, so you will get x of at minus b. so इन दोनों ऑपरेशंस में से जो दो चॉइसेस हैं इनमें से इस चॉइस में हमने पहले टाइम शिफ्टिंग परफॉर्म की है और इस चॉइस में हमने पहले टाइम स्केलिंग परफॉर्म की है. सो कौन सा ऑपरेशन, क्या ये पहली बात तो ये है कि क्या इन दोनों ऑपरेशंस को, जैसे कि मैंने कहा कि किसी भी सीक्वेंस में आप परफॉर्म करें तो क्या इनका रिजल्ट सेम आएगा या रिजल्ट सेम नहीं आएगा. सो लेट्स सी कि अगर तो रिजल्ट सेम आता है तो देन तो ऑब्वियसली ऑर्डर इम्पॉर्टेंट नहीं है, लेकिन अगर रिजल्ट सेम नहीं आता तो then the order is important and we have to perform these operations in some specific order. Okay students, this is an example which demonstrates that the order of the precedence, the order in which these operations of time shifting and time scaling are performed is in fact important, because if that had not been important then we should get the same result in both cases. However, the results are different. So we start from a signal x of t which is non-zero from point -1 to +1. So if we what we are going to transform this signal into, that we want to generate a y of t which is x of 2t plus 3. So basically the operation which we are going to perform has to time shift as well as time scale the resultant signal. So what if we first perform the shifting operation? So if from x of t, which is non-zero from -1 to +1, we generate a signal which is x of t plus 3. So this will in fact, the signal will be non-zero from points -4 to -2. And how you determine that? You just put this argument t plus 3 equals to the point. For example, when you put t plus 3 is equals to -1, so then t becomes -4, which is this point. Similarly, when you put t plus 3 is equals to +1, then t becomes -2, which is this point. So this was the time shifting of operation performed on this signal xt by an amount which is equals to +3 units. Now after that we have to perform an operation which is, this signal is say v of t, so we have to perform v of 2t, because finally ultimately we have to generate a signal which is x of 2t plus 3. So this y of t which is given as v of 2t, if we will construct it, it will be non-zero from between the points -2 and -1, and that you can easily determine because this was v of t and now you are going to generate v of 2t. So you will put this point 2t is equals to -4, which will become t is equals to -2. Similarly 2t equals -2, so this becomes t is equals to -1. So this signal now exists between is non-zero between these points -2 and -1. So here we have first performed the time shifting operation and then we have scaled the signal, and the final result is we have generated a signal y of t which is x of 2t plus 3. Now see, let's see in the bottom diagram we have performed these two operations in the opposite order. First from x of t, which was again non-zero between -1 and +1, we generated a signal which is x of 2t, and again using the same methods, so we are going to generate x of 2t, so we will put 2t is equals to -1, which will become t will be equals to -half. Similarly, when 2t will be +1, t will be equals to +1/2. So x of 2t now exists from between -1 -half and +half, and then we have to shift this signal by an amount which is equals to 2t plus 3, because finally we have to obtain x of 2t plus 3. So if we do that for this signal, this minus half point, this will go to, because this was minus 0.5, so it will go to minus 3.5, and this plus half point will go to the point which is minus 2.5. now you can see that these two signals are not equal, so it means that the operation, the order of the operation in which these operations are performed is important, because if you will follow these two steps, first you will perform shifting and then scaling, the resultant signal would be this one. And if you will first you perform scaling and then shifting, the resultant signal is this one. So it means both of them could not be correct, so only one of them would be equals to correct. So that is basically the message, the point, that this thing is important, that which operation you are going to perform first. Okay, so here is an example of a discrete time signal operations, which are basically uh, discrete signal shifting plus scaling. So as I have earlier demonstrated, that if you have to use more than one operations, then the precedence rules are, first we will have to do the shifting of the signal, and then we have to do the scaling, time scaling. So this example demonstrates a little bit, is a little bit different than the continuous time case, and the reason is that in discrete signals, because discrete signals are only defined, only exist at integer intervals of time. So whenever we perform compression, remember that we perform compression when we are generating x of 2n or x of 3n or x of 4n from signal x of n, then we may lose some points. And the reason for losing those points are, or those values are, that during this process of compression, some sequences, some signals, as a result of this compression, come to those points which are not integer. So those points we will lose them in the final compression. So let's see what we are going to do. So our signal x of n is has a value -1 at these points, -2 and -1. Its value is 0 at n is equals to 0, and its value is 1 at n is equals to 1 and 2. And besides these 5 points, the signal xn is 0 for all other values of n. So first we have to generate final signal x of 2n plus 3 from this signal. So first we will generate x of n plus 3 from this x of n. So it means we have to shift this signal towards left by 3 units. So each point of this signal will shift towards left by 3 points. So the point which exists currently at n is equals to 2, that will go to at n is equals to -1 in the shifted signal. Similarly, the point, the value which exists at n is equals to 1 will be shifted to n is equals to -2 in the shifted version, and the value which at n is equals to 0 will be shifted to n is equals to -3. Similarly, for -1 and -2, corresponding shifted signal will exist at -4 and -5. So after this shifting, the next operation which we have to perform is time scaling, where we have to generate x of 2n plus 3 from this signal x of n plus 3. So basically we are going to compress this given signal x of n plus 3, and our compression ratio is twice, so we have to generate x of 2n plus 3. So let's see what happens. The point which exists in x of n plus 3 at n is equals to minus 5. When we want to draw it in x of 2n, so this will exist at minus 5 by 2, but minus 5 by 2 is minus 2.5, and that is not integer, so this value will be lost. The next point which exists at n is equals to minus 4 in x of 2n plus 3, that will exist at n is equals to minus 2, because minus 4 will be divided by this 2, so this point is there at n is equals to minus 2. Similarly, this point which exists in this signal at n is equals to minus 3, this will also be divided by 2, so minus 3 by 2 is minus 1.5, but again it will be lost because this is not an integer. This point which exists at n is equals to minus 2 in xn plus 3 will also be divided by 2, so this will be there in at n is equals to minus 1 in signal x of 2n plus 3, and the signal which is present at n is equals to minus 1 in xn plus 3 will also be lost, because when it will be divided by 2, it will be going to point minus 0.5, which is not integer. So as a result of this compression, although our original signal has 4 non-zero points, as a result of this compression we only get 2 non-zero points in our signal, and that will happen whenever, as a result of some compression, you get some points which are not integer. So in that case you will lost a few values of that signal. Okay, so here we have a signal which x of t, which is given like this. So from this signal, as a homework exercise, you have to draw a few signals, and the first signal which you have to draw from this signal is x of t plus 1. So x of t plus 1 is an advanced version of this signal, so you can easily draw that signal. आप इसको शिफ्ट कर सकते हैं, इसका एडवांस्ड वर्जन जो है वो फाइंड कर सकते हैं. एंड सिमिलरली x of minus t plus 1, if we are talking about x of minus t plus 1, so here basically from this xt we have to obtain x of minus t. So from this xt, how can we obtain x of minus t? We can obtain x of minus t by reflecting it around this vertical axis. So x of minus t will look like, ये signal x of t 0 से 2 तक exist करता है, so x of minus t will be from 0 to minus 2. नेगेटिव पोर्शन जो इस वक्त नेगेटिव पोर्शन है ये पॉजिटिव साइड पे चला जाएगा. पॉजिटिव पोर्शन जो इस वक्त पॉजिटिव साइड पे x ऑफ t में जब आप रिफ्लेक्ट करेंगे तो ये नेगेटिव साइड पे चला जाएगा, और उसके बाद आपने इसको शिफ्ट भी करना है. अच्छा, यहाँ पे अगर आप देखें तो यहाँ पे भी आप दो ऑपरेशन परफॉर्म कर रहे हैं. वन ऑपरेशन इज द रिफ्लेक्शन, जिसमें आपने ओरिजिनल सिग्नल को रिफ्लेक्ट किया अराउंड द वर्टिकल एक्सिस, और दूसरा ऑपरेशन जो है वो शिफ्टिंग है. सो यहाँ पे हमने एक केस ये हो सकता है कि आप पहले इस सिग्नल को रिफ्लेक्ट करें और उसके बाद शिफ्ट करें, और दूसरा एक चॉइस ये हो सकती है कि आप इस सिग्नल को जो है वो +1 से शिफ्ट कर दें और उसके बाद जो रिजल्टेंट सिग्नल आपको मिले उसको रिफ्लेक्ट कर दें. सो यू हैव टू चॉइसेस. फर्स्ट चॉइस इज फर्स्ट रिफ्लेक्शन देन शिफ्टिंग. सेकंड चॉइस इज first shifting then reflection. Now for this particular set of operations the order is not important and you can easily see this from this example. आप इस सिग्नल को ये दोनों तरह से कर सकते हैं. पहले आप इसको रिफ्लेक्ट करें उसके बाद शिफ्ट करें, या पहले शिफ्ट करें उसके बाद रिफ्लेक्ट करें. you will get the same answer. So it means here the order is not important. Order is only important when the shifting and scaling operations are combined. shifting और reflection जहाँ पे combine हो रहे हैं, जो इस केस में है, तो वहाँ पे order important नहीं है. similarly scaling और reflection अगर कहीं पे, वैसे scaling भी reflection ही है, लेकिन अगर वो कहीं पे combine हो जाएं तो उसमें भी order important नहीं है. order is only important when you have to perform time shifting and time scaling. So then you have to follow those steps जो हमने पिछली स्लाइड में डिस्कस किए हैं कि कौन सा ऑपरेशन आपको पहले परफॉर्म करना चाहिए, कौन सा ऑपरेशन जो है वो आपको बाद में परफॉर्म करना चाहिए. In third case is you have to generate a scale version of this signal x of t, x of 3 by 2t. So इस x of t से you can easily generate x of 3 by 2t. कैसे वो हम इस लेक्चर में डिस्कस कर चुके हैं. And the fourth operation is x of 3 by 2t plus 1, which is basically a combination of a scale of time scaling and shifting. So here you have to follow those instructions जो हमने examples में एक slide पे discuss की कि जब ये scaling और shifting का operation combine हो जाते हैं तो उनमें से कौन सा operation आपको पहले perform करना चाहिए. But this is also a solved example in the book of Oppenheim, but I will advise you to first try at your own and then look at the solution, because in that way you will be able to have a grip on these very basic operations जो आज के लेक्चर में हमने सीखे. Okay, these are a few more problems for your home practice. Here we have a signal x of t which is shown like this. इसकी wave form आपको नजर आ रही है, and same is true and another signal which is a discrete time signal x of n is given over here. So in this case you have to generate the first is x of t minus 1, shifted version of this x t, then x of 2 minus t. This x of 2 minus t, by the way, will be if I ask you what are the operations over here, so this is x of t, to x of 2 minus t में you have to obtain x of minus t, which is a reflected version of this signal, और फिर उसको you have to shift by an amount equals to 2. So इसमें shifting और reflection जो है वो combine है. X of 2t plus 1, scaling and shifting are combined. You have to scale it with 2 and you have to shift by an amount which is 1. X of 4 minus t over 5. So here you have to basically this is reflection and what do you call it, scaling and shifting. So all three operations you have to perform in this case, because this is x of t, so from this x of t you have to get x of minus t, और फिर उसके बाद x of 1 over 5t, x of minus 1 over 5t, so you have to scale it as well, और उसके बाद shift भी करना है. So ये तीनों ऑपरेशन आपके पास कंबाइन है. अब इसको भी परफॉर्म करने के लिए you will follow those steps जो हमने डिस्कस किए हैं कि जहाँ पे भी शिफ्टिंग और स्केलिंग आपस में आपके पास जो है वो कंबाइन होती हैं, तो उनमें से जो ऑर्डर है, किस ऑर्डर में कौन सा ऑपरेशन जो है वो पहले परफॉर्म किया जाता है. सो यहाँ पे भी आप वही स्टेप्स फॉलो करेंगे और वो वाला ऑपरेशन जो है वो पहले परफॉर्म करेंगे. उसके बाद ये कुछ डिस्क्रीट सिग्नल के लिए भी है. ये x ऑफ n है जो आपके पास डिस्क्रीट सिग्नल है. सो x ऑफ n माइनस 4 पहले केस में आपको चाहिए just simple shifting by an amount equals to 4. X of 3 minus n, which means the reflection around the vertical axis, and then shifting by an amount equals to 3. X of 3n, a scaled version of original signal, since you have a here is greater than 1, so it will be जब आपके पास a की वैल्यू ग्रेटर देन 1 होती है तो ये जो आपके पास रिजल्टेंट सिग्नल आता है that is a decimated version of the original signal जो compressed होता है. X of 3n plus 1, here you have to perform two operations. X of 3n is time scaling और फिर उसको shift भी करना है, so you have to follow those steps. Okay, so some important points which we discussed in today's lecture, let us briefly revise them, what we have discussed. So x of t minus capital T is the signal xt shifted to the right by T capital T units. So x of t minus t is a shifted version of the original signal x of t, but this is shift right. The signal will be shifted towards right. X of t plus capital T is the same signal xt shifted to the left by capital T units. So x of t plus t is left shifting, x of t minus t is right shifting. X of minus t is the reflected signal flipped around the vertical axis, जो आप vertical axis के around flip करते हैं. X of at is the signal which is compressed by a factor a. Similarly, x of t by a is the signal which is expanded by a factor a. So compression and expansion in continuous domain, और अगर हम discrete domain की बात करें तो this is called decimation and interpolation. For combined operation where you have to perform more than one operations, and that order is particularly important when you have to shift scale these two operations. Particularly shift and reversal is not a problematic operation. Similarly, scale and reversal is also not a problematic operation, but if you have somewhere combined shift scale or all three of them, shift, scale and reversal, then it is important to first shift and then scale. So this order is important. You cannot do it the other way around. You cannot first scale it and then shift it. The order is first shift the signal and then scale. As far as reversal is concerned, reversal can be performed anytime, even before shifting or scaling or after shifting or scaling. Okay, so there are a few practice problems for your homework. If you want to do them, 1.3, 1.23 and 1.24 in your book, which is Signaling System by Oppenheim, and in those problems you have to perform these very basic operations. So today's lecture was about some fundamental operations which can be performed on dependent variable as well as independent variable. So we have discussed magnitude scaling, where you can enhance or you can increase or decrease the amplitude or magnitude of the signal by multiplying it with a factor k, and depending upon the value of k, whether k is greater than 1 or k is less than 1, your resultant signal will either be scaled up or it would be scaled down. And then we discussed a few operations on the independent variable, where we discussed time shifting, time scaling and time reversal. So these operations which we have discussed today are important, and we will very soon return to these very basic operations when we will talk about some systems, because normally to the systems, and signal is applied at the input and then system generates an output. So basically the output signal in one way or the other is some operation similar to that what we have discussed in this lecture is performed by the system. Then we also have to discuss the convolution operation, and there you will also see the shifted and scaled version of the original signal. So please, I would advise you uh, to practice a little bit about these basic operations, because we are going to use them again and again in the study of this course. So if you want to, for example, want to study this, you should study this from your book Oppenheim. This is section 1.1 and 1.2, which talks about these very basic operations. So with this today's lecture we will end it over here. So till next time, thank you. अल्लाह हाफिज़, अपना ख्याल रखिएगा और कोविड-19 से एहतियात कीजिएगा. Thank you very much.